Thank you. All right, guys, are there any questions on any of the assignments thus far? All right. If there are no questions on any of the assignments, what we're looking at today what we're going over today is the properties of trapezoids, the properties of trapezoids. Now, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Now, the parallel sides in a trapezoid are called the bases. And the angles attached to the bases are going to be called base angles. Now, the two sides that are not parallel are called the legs. And they're going to be two legs in a trapezoid. Now, when those legs are congruent, well, apparently I'm going to scroll up. When those two legs are congruent, we call it isosceles. And we talked about isosceles triangles. And on an isosceles triangle, we had two congruent sides. In an isosceles trapezoid, we have two congruent sides. Isosceles is telling us that we have two congruent sides. Now, with isosceles trapezoids, they do have some special properties. The first one tells us if a trapezoid is isosceles, then each of the base angles are congruent. They're going to have the exact same value. Well, the converse is also true. If a trapezoid has a pair of base angles that are congruent, then it's going to be isosceles. So if a trapezoid is isosceles, then the base angles are congruent to each other. If we have a trapezoid with a pair of congruent base angles, then it's going to be isosceles. They go back and forth. And one of the other main properties that we have is if the diagonals in a trapezoid are congruent, then it's going to be isosceles. If a trapezoid is isosceles, then the diagonals are congruent to each other. So, any questions over any of this so far? So, let's look at the first one here, and let's close the Chromebooks, get your phones out. Thank you. So when we look at the first one here, the stone above the arch in the diagram is an isosceles trapezoid. Find the measure of the three missing angles. K and L are base angles because they're attached to the same line that is parallel. And since it's isosceles, the base angles are going to be the same. So the measure of angle K is 85 degrees. Now we still need to find the measure of angle J and the measure of angle M. What can we do to find those? Well, the angles that are between parallel lines are going to do what? Add together to be 180 degrees. 85 from and 180 minus 85 would be 95. So the measure of angle M is 95 degrees. What does that tell us about the measure of angle J? It's also 95 degrees. Because the base angles in an isosceles trapezoid are congruent. The base angles in an isosceles trapezoid are congruent. Any other questions on this here? All right, let's look at the next one. So we need to find the measure of angle B, measure of angle C, and the measure of angle D. So we look at this here. Because it is an isosceles trapezoid, so the base angles are congruent. So B and C would also be congruent to each other. And since C and D are non-base angles, they're not on the same line, but they do add together to be 180. Huh? So we can take 180 and minus 42. 7 and 10 would give us 8. 7 minus 4 is 3. 1. So the measure of angle C is 138. What about the measure of angle B? It'd be the exact same. What would happen if we add all four of those angles together? Because the sum of the interior angles of any four-sided figure has to be 360 degrees. What's the sum of the exterior angles? 360. Because the sum of the exterior angles is always 360, no matter what it is. Okay. Let's look at this one here. We want to find all of the possible angles. We know S is 65. What other angle do we know? P would be 65 if it's an isosceles trapezoid. Right, so these two sides here are parallel.
We can find R by subtracting 65 from 180.
Yes. Which would be 115 degrees, yes. So the measure of angle R is 115 degrees. But we do not know if it's isosceles, and it doesn't tell us anything about the lengths to be able to find it. Well, we could say they add together to be 180, yes? Can we say anything more than that? No. So the only real angle that we can actually find a value for is R. So it could be 90 or it could be 89 or 88, but we don't really know what it could be. So really the only angle we can actually find is R. Any other questions on this here? Let's look at this last one of this type here, and then we'll move on. So if we look at this here, because we can do 180 minus 60, 0. 8 minus 6 is 2. Drop the 1. So 120. What else do we know? Because the base angles in an isosceles trapezoid are congruent. And that's it. Questions on this here? So we'll move on to this here. HEF is 70 degrees. FGH is 110 degrees. Can we say that this is an isosceles trapezoid? So how can we go about doing that? 180 minus 70 would be 110. So what did we just find? H. So this is 110, yes? So one of the first theorems that we covered today was isosceles trapezoid base angle theorem. If a trapezoid has isosceles, then each pair of base angles is congruent, yes? Well, that doesn't help us much because that's if it is already an isosceles trapezoid. But the next theorem, the isosceles trapezoid base angle converse, states if a trapezoid has a pair of congruent bases, then it is an isosceles trapezoid. Were we able to just show that? So can we say this is isosceles? Yes. We do have enough information. So that means that our other angle is going to be 70. We ready for the next one? Okay. This here tells us that EG is congruent to FH. Is this enough information to say that the trapezoid is isosceles? Because what was the third theorem that we had? Which states a trapezoid is isosceles if and only if its diagonals are the diagonals congruent? Yes.
So if EF and HG were both the same length, would that make that a square, right?
Well, it wouldn't be a square because all four sides are not congruent. All four sides would not be congruent. Now, proving that this is isosceles is actually not that bad of a proof. But I have a feeling y'all would be more bored with it than enthralled. Because if we look at this here, well, we've already had that these two sides are congruent. And we have this shared third side. And because of our, let's see here, and then we could talk about the angle between the sides. So by side angle side, we could show that these two triangles are actually congruent, which means these have to be congruent as well. Okay. Km is 22. It's an isosceles trapezoid, so what is? Because the diagonals are? Because it's isosceles. (8.7) because again the diagonals are congruent. And I mean, we could make these quote unquote harder. I mean, we could put two equations for each diagonal, find the length. Well, that's just still setting the diagonals, setting the two equations equal to each other, solving for the value of x, and then plugging it back in. So is it really making it any harder? Well, no, it's just making more steps to solve it. The last thing we're looking at today is this here, the trapezoid mid-segment theorem. The mid-segment, which is accurately named because mid meaning middle, and it's a segment. So the middle segment, this middle segment is equal to half the length of the other two bases. The length of the mid-segment is equal to half of the length of the two bases. So if I wanted to find out what this length is, well, I could take y plus z and multiply it by 1/2, and I would get the mid-segment. And it works out that the mid-segment's length is actually in the middle of the two others. So if we look at an actual example, this here, yes.
So y is 6 and z is 8 and it'd be 7.
Yes. And it's always going to work out that way, that the mid-segment's length will be between the two sides. So the length of the mid-segment for this here, whatever it is, if we didn't know what it was, and we had 6 and 8, well, this value cannot be less than 6, and it cannot be greater than 8. It has to be in the middle. So if we're looking at this problem here, we know that the mid-segment cannot be smaller than what? It can't be bigger than 28. It has to be between those two. So if we wanted to find this and we wanted to write this out in a pure mathematical sense, we could say that mn is equal to half of pq plus xr. Well, really, we could say that whatever our length is, and we're wanting to find x, that mid-segment is equal to half of what? 12? Well, what is 12 plus 28? So we're taking half of, which is, so the mid-segment, mn, is 1. Eric, there's 2 things on the printer, or print lease, if you can go let those go. Yeah. Yes. If you type that in after login, it'll be the center top button, and just release everything. Any other questions on this here? So let's look at the next one. So we want to find the mid-segment mn. It's in the middle, so the value should be between them. So what we could say is that the mid-segment's length is equal to half of highlighter. Is everything that I just highlighted all numbers on the same side of the equal sign? What can we do with that? Plug it into the calculator. Calculator can do all of that. We don't have any variables in any part, and we don't have to manipulate it to get the variable by itself. It's already by itself. So we could plug all that into the calculator. Now we can add these two together. 4, carry the 1, and get 32.4. And if we divide it by 2, so we get that mn is 22. And that's all we have to do for this here. Any questions on any of this here? You all feel comfortable with this here? Yeah. Right. Now this is the order's a little different than what you have, so we'll skip number 12, which has, you can go to the bottom of it. Y'all find this one here? Now, they already told us the length of the mid-segment, yes? So the length of the mid-segment is equal to what? Half of which we can call x. We can, but there's an easier way to do this. If I multiply this entire side by 2, what is 2 times 1/2? 1. This here would simplify to 1 and would cancel out. So if I multiply both sides by 2, the 2 times 1/2 would simplify, leaving us with 13 plus x. On the other side, we have 2 times 19, which is 38. Yes. What is the difference between 13 and 19?
6. Well,
So the difference here would be
6. See,
19 plus 6 is? Now in the equation, the first thing we did was multiply by 2 because we wanted to eliminate this 1/2. The 2 and 1/2 would cancel, but what we do to one side, we have to do to the other. So 2 times 19 would give us our 38 is equal to 13 plus x.
So you just find the difference between your top number and your middle number and add that to the.
Mm-hmm. But instead of adding, we would subtract. So here, what's the difference between these two? Point.
So you just add that point by multiply.
Mm-hmm. Any other questions on these here? All right. Let's look at this one here. So we skipped it a minute ago. Mm-hmm. Now I changed it from the top number being 23 to 2x plus 4. So this did have 23 written here. And it still does, because I changed it this morning. So cross it out and let's put in 2x plus 4.
Half of 11x plus 2 becomes 2.
So the mid-segment is what? So we're saying that the mid-segment's length is equal to 1/2 times 2x plus 4 plus 11x plus 2. Because this is just the equation for mid-segment. Now we can add like terms to start with. So we'd still have the 29 equals 1/2 times, yes, the 29 equals 1/2 times 13x plus 6. Because our 2x and 11x would add together to be 13. Our 4 and 2 would add together to be 6. We're going to multiply both sides of the equation by 2. So on the left-hand side, we have 2 times 29. And 2 times 29 is 58. On the right-hand side, we now have 2 times 1/2 times the quantity 13x plus 6. Well, 2 times 1/2 is 1. So this simplifies to 1, leaving us with just 13x plus 6. What can we do next? $52 is equal to, divide 52 by 13. X is equal to?
I don't have a calculator.
13 times 4, well, 4 times 3 is 12, so 2 carry the 1. 4 and 1 is. Then we can plug it back in. So on bottom here we have 11 times 4 plus 2.
46.
11 times 4 is 44, plus 2 is exactly 46. And the top would be 2 times 4 plus 4. Well, the difference between 12 and 29 is what? 36 is also 17.
If you have a constant number on, or an even number on top and an even number on the bottom,
let's see here. One 16. Not always, because see here, 12 and looks like it. Yeah. Looks like most of it would be even. But that is it. That's all we're doing for today. So your assignment is on page 365, problem 7 through 12 and 28.